So hey everyone, in this video we are going to solve the today's LeetCode question problem of the day, that is number of substrings containing all three characters. So what does the question say? We have to tell the number of substrings that contains A, B, C, at least one occurrence of each of these. So let's see the approach. We have a string A, B, C, A. Okay, so what is the first approach that comes to our mind? That is brute force. What do we do? We iterate over the entire string for I to n, then from right, then we take j equals to I to again n, right? And what do? We keep three pointers, right? We keep track of the occurrences of a, b and c, right? When a, b and c all greater than 0, then what do? So let's say we are at any index j. This is our total length of string n and this is I. So you see, at from I to j, now we have at least one occurrence of a, b and c, j each, right? So what will the total number of strings that will contribute to the answer? So let's say we have a, b and c at this position we have all, right? So next will be a, b, c, a. Okay, so that will be n minus the j. So at if we are at, let's say, any n index I, then total number of string that will contribute it n minus I, right? All substrings that we can form after including the current character. So the time complexity will be n cross n. So obviously this will not work with the interval. So what other approach is? That is of n approach that we can do is using two pointers. So this is the approach that interviewers generally expect when they ask this question. So what happens? Let's say you will keep track of left and right. So at any position you have a L and you have a R, right? And in between L and R you keep track of A, B and C's occurrences, right? So if at any index R you have A greater than 0, B greater than 0, C greater than 0, then you update the answer by answer plus equals to n minus R. Then what do? You go ahead and then shrink the window. That is, you remove the, let's say, what is the S, what is our character at Lth position, you decrease its occurrence and then you go ahead and update L, that is, you shrink the window. Let's see it by example. So we have A, B, what do we have, and C and A. So initially L equals to 0, R equals to 0. Okay, so we'll do a loop, right? We go and we increase our R, then R becomes 0, R becomes 1, then A becomes 2, right? Then here B becomes 1, at here C becomes 1. Now when R equals to 3 and L equals to 0, we have all occurrences of A, B, C and all are greater than 0, right? Then what it will contribute to our answer plus equals to, what is the total length of the string, that is 5, minus what is the current position of C, that is 3. So it will contribute to the answer 2. Okay, then what do? Now since we have all occurrences of A, B and C, now we will shrink the window, that is, we will shrink the L and see, do we have another index from which we can get all these occurrences. So what do? Then inside we update the L, we move it here, then we remove this one occurrence of A. Now becomes A1, B1 and C1. Okay, so we still all are greater than 0. Then we again do answer plus equals to 5 minus 3. That is our R position, right hand. Then we again go and this time it becomes A0, B1 and C1, right? So then we go ahead and we move our R till we again get the at least one occurrence of each of these. So now this is our L, here we are for L, and then we increase our R. So our R becomes 4, L becomes 2, and we again have A greater than 0, B greater than 0, C greater than 0, right? That is 1, 1 and 1. Okay, so So we again add it to our answer plus equals to 5 minus what will be the value of our 1. Okay, so what will be our total answer? 22415. So let's see what do we have from the string. So we can do a b c, one substring. We can do a b c a 2. We can do a b c 3. We can do a b c a 4, and we can do b c a 5. So these are the all we can form. So this is the of n solution. Now let's see how we implement it via code. Okay, so now since we have the approach and we have discussed what possible approaches we have, like one, when we do a binary search with the next possible index and we choose a maximum of a, b or c, and then subtract it from the total length of the string, and we get the total number of substrings. And the of and time complexity approach is using pointers. So let's see, we'll make a array int count equals to new count. We'll make it 3 size. Define left 0, right equals to 0. Run a loop while r less than s dot length. Just define int answer equals to 0, where we keep track of our answer. Inside this, what we will do, we'll update the count s dot char I minus a. We'll get the index of the character and we'll update it. Since you see we only have a, b or c character in the string, so we can safely do this. And we'll increase the counter by 1. Now what do we need to check? Check if we have at plus 1 occurrence of each of these. If yes, we add it to answer and shrink the window. Okay, so I'll count of 0 greater than 0, and then count of 1 greater than 0, count of 2 greater than 0. What do? We say answer plus equals to s dot length total minus our current position. So this much number of substrings can be formed. Then what do? We decrease the count caret left, this will be caret r minus a. We decrease the count, we increase the pointer, and we again check if it's greater than 3 or not. Then we update our r, we return the answer. Let's see, does this make sense? So r less than is correct. So L can never be greater than R, because then this will be 0 and our this condition will become false. Okay, so yeah, this makes sense. So it will be new end. Switching from C++ to Java is very difficult. So yeah, see, that's it. Submit. Okay, here we go.